Okay, harder tap. Wow! That actually handled that. In the previous video, we experimented with all the different ways I could think of making 3D printed heat sinks if you have an FDM printer, something that takes plastic filament. Now, the PLA heatsink acted like an insulator and basically got in the way, but the copper composite filament, it didn't get in the way, and it seemed like it did have a little bit of thermal conductivity. Now, the professional high-grade $250 spool of Ice 9 PETG, which has a thermal conductivity of 3.0, actually worked fairly well. It's a little bit picky about which orientation you print the heatsink in, but it almost worked. However, the queen of heatsinks is still aluminium and copper. Aluminium has, what was it, like 150 times? Well, no, like 90 times the thermal conductivity, 237 watts per meter Kelvin as opposed to 3. And I had wanted to finish this whole collection with a metal 3D printed heatsink. I went to PCBWay and I put it in an order. I just felt bad. It's like, I shouldn't spend that money on that. I should just do without. But then PCBWay sent me an email wanting to sponsor a video, and it's like, well, okay. I wanted to think of other things and have them sponsor a few videos, but I just had them make me a whole bunch of heat sinks because I couldn't think of anything else to have them make. So we have a whole lot of 3D printed aluminium PCBWay heat sinks. And what's funny is whenever you print this many of them, they end up going down to like $5, which is actually a pretty good deal. Or maybe more like $7 at this number. But you can go down to like only a couple bucks for these. So if you're making a product and you wanted a small custom heatsink for, say, a artistic LED light, that actually works out pretty well. Now, it's been about a decade since I ordered a 3D printed metal part. The last time, and only time I did that, I used the company card. Back when I worked at Apple and I had that corporate Amex card, and I was like, well, I'm going to order one, but I ain't paying for it. And so I'm really curious to see how the print quality has changed. Well, here's how the base of these heat sinks look and how the tops of the heat sinks look. And then here's the base under a microscope and the top under a microscope. What I did was I got myself a piece of factory glass and I polished, sanded the base of one of them. Now what's interesting is on this one that I sanded, I also sanded the top as well. Here's a view underneath the microscope. You can see the lines of the laser sintering, but then you can also see this brush stroke mark, which is the sand blaster that they use, the media blaster, to clean them off. I thought that was kind of interesting. I stopped right there because I wanted to see that sandblasting mark, but it would be easy to sand that off as well. Now, I also had them make me a few of these tiny little heat sinks, and I figure maybe the part for this video could be, we'll do the test of the big heat sinks. My test only produced 2 watts of heat, and 2 watts of heat might be too tiny for these big heat sinks. So let's also go back and test the tiny little heat sinks and then see, because I think 2 watts of heat would be a better task for this tiny heat sink. And firstly, what I need to do is take one of these tiny ones, get myself some plate glass, and start sanding the base. As we have our piece of factory plate glass, I'm going to put down some water. This is some 400 grit sandpaper, a little bit coarse, but oh well, this is used sandpaper, so not the best, but the reason why we use float glass is because this glass was produced when it was floating on top of molten tin, so it's extremely flat. And then you just put the sandpaper on top of it, and it's already starting to come through. Could you grab me a paper towel? That's what I forgot, a paper towel. Don't forget a paper towel. You can see the laser sintering line starting to appear here. Let's continue. I went a bit long on this, but I really wanted to see how much could you sand it down to. The answer is quite a bit. It doesn't seem like there's any inclusions at all in this 3D print, and it looked the same for the other one as well. I just didn't go down a whole lot because that was a bigger heatsink. But for this one, it was actually really easy to go down to the point where I imagine it would be pretty much solid, and you could have a mirror, at least for the most part. If I switched to a finer sandpaper, I could have a mirror. Now, I recently had somebody rage quit one of my videos because of what I do with my microscope. They said that I abuse it. Now, I don't know about you, but I think what I do with my microscope is very versatile. Oh, interesting. Look at that. So that's the surface of the base of the small heatsink. That's a really smooth heatsink. Could you take the light and make it more like down to here? Because I get a different reflectivity. Yeah, so then we can see the cross lines because my hands tended to stop going in one direction and then go in the other direction. Funny how that works. Or this could be laser sintering lines. They are kind of evenly spaced. That's pretty fascinating. And now for comparison, I'm just going to hold the other one. Yep, about what I expected. Moon surface. So first we'll go just the same materials, same setup as the previous video. A piece of paper to show the heat, a dollop of Arctic Silver number 5. And the polished heatsink. Same dimensions as everything else. Oh, the wire is actually bent a little bit. And now we power on and see how it does in 5 minutes. Running at about 2, maybe 2.3 watts of power. I would like to move the camera closer so we can see what is going on. This heatsink is doing an amazing job conveying the heat. I can feel it with my hands. Yeah, I can feel the heat flowing up. And it's keeping the temperature low as well. This is a really good heatsink. I'm partly hoping to make a product around this, honestly. Now, one thing to note is that the main difference between this heatsink material and the others is that this, being made of metal, is highly reflective, and so it looks like a mirrored finish. You see, the outside of the heatsink looks like it's colder. That's just because it's reflecting our kitchen. And the inside of each flute, I guess you'd call it, is more indicative because it's just reflecting itself, and so you get a more realistic temperature. So, judging by what I'll call the flame around it, this beautiful convection current, it is very, very easily moving all of this heat to every corner of the heatsink. Whereas the other filaments had issues of the base being a constriction point, this does not have that issue. And it's even being able to keep the LED from going above like 50, maybe 53 degrees Celsius, which before it was getting hot enough to smell a little bit funny. So this is a really viable design, and honestly, I'm really impressed with this 3D print. I wish I had the money to buy a bunch of these. I really do. So now, the test that I didn't show too much in the previous episode is turning it off. Let's turn it off now. It is now off. And with the other heat sinks, it took way too long for it to cool down for the most part. However, with this one, I wouldn't be surprised if it takes way less than 10 minutes to cool down, because this heatsink is really just sucking up all of the heat. I've now modified our setup to have a smaller hole to fit the tiny heatsink. We're starting with the Protopasta Copper Composite HT-PLA, which we do not know the conductivity of, but we are not trying the PLA today because I didn't print one and it didn't work too well. Well, let's turn it on. I wish this software was, I wish I could set the ranges customly. Whenever this app was on the App Store, I could have sworn I could do that, but now I can't. So I would love to set 29 degrees as the lowest temperature and then 40 degrees as the highest, so it wouldn't adjust the temperatures down. As it is now, it auto-adjusts the temperature range, and that doesn't really work for our eyes as much, because whenever the heatsink is hot, it looks almost the same, just less static in the picture as whenever it's cooling down. So you have to keep that in mind if you're judging. Oh, getting a little bit of convection already. So it's been about 5 minutes, and I do worry that this isn't cooling it enough. Oh, wow. Yeah, that's way too hot. Okay. Turning it off. Putting the paper back. Wow. Okay, I burned my finger on that. All right, it's been enough time for this to cool down. That was way too much heat. So that's one danger with this, that these small ones might get oversaturated with heat. Now I'm trying the Einstein PETG printed the most efficient way. And turning it on. The previous one, that got way too hot, but hopefully this one can dissipate heat more. However, honestly, the profile of this seems to indicate that it's similar to whenever I ran this LED without any heatsink at all. So I think these ones might be actually too small, now that I think about it. The only one that can come out on top probably will be the aluminium one. All right, it has only been about 3 minutes, but I'm actually gonna have to call it there, because again, yeah, that's just way too hot. That's getting up to let's see, 51. Yeah, 51, which, because that's very reflective, it's probably something like, it feels like 60 degrees Celsius. I don't want to burn out these LEDs. So I feel like maybe, yeah, these are a little bit too hot. Well, I guess since I'm here, I might as well put this one on there. And it's so flat that I don't need to add any thermal paste to it. I can just squish it right on there. And let's see. How does that suck up the heat? All right. Right. It's reflective, so it wouldn't be quite the same. Oh well. I'm going to give this about 10 minutes to cool off, and then we can give this one a try. I guess these small heat sinks they're not that great. I might want to think of a different design for smaller power. I don't know. I don't like getting those LEDs near that temperature where they start to smell kind of funny. They start smelling like a 3D printer. So guys, I actually made a mistake, and this paper was stuck in the front. So I reshot it after poking it to the middle. And here's that one. I just turned off the LED, and I just want to get some quick shots of it. I know it's almost pointless to get a shot of it because it, oh, right. It's so reflective, but it is still getting a little too hot, so I guess this is better for an even smaller circuit. Something that already could almost do passive cooling anyway. All of these tests show that, especially for the 3D printed metal from PCBWay, the heat flow through the part is just perfect. The issue is the design and maybe the placement. So with these did have good convection, but it might be good to also have something to make sure there's nothing flat underneath it. For instance, having them sit on this, that's a flat surface, and air has to come in and do it at 90 degrees. But if it's just on an LED that kind of hangs somehow, air can kind of come in and not have to move very much. But these, it feels like this design is a little bit too confined for a passive cooling. So this one might just look nice and not be super good. Although if I were to punch out the inner bit, it might actually make it work better. Hard to say. I didn't buy these heat sinks. They were sent to me to test and for me to spread awareness about how good the product is. And so for that, I can't act like it's something that I paid money for. It's something for a test. So get your view up nice. You're gonna start with a light tap. It's funny, it sounds like hitting a heat sink. Hard tap. No issues. And now, as hard as I'll go. And some of the other heat sinks popped off and no damage. Okay, harder tap. Wow! That actually handled that. Huh! Wow! Oh wow, okay. Wow, that is actually really strong. That Well, man, I can't believe it. It's starting to deform just enough to make it shiny, but gosh, I thought the base would crack or something. Then again, maybe I made a pretty sturdy design. Well, I don't know what to, yeah. So we're gonna call it there. I wish I had money to buy a whole bunch of stuff 3D printed, but maybe in the future. If you do, seems like this is a pretty good investment. That is so cool. Well, thank you very much, PCBWay, for sending us these. It's so nice to see my design finalized, and you know, I don't imagine this is gonna... Oh, it actually flipped upside down. Because I had it upside down. Because me hitting this made everything jump up. Wow! I must have made a really strong design.
Must have.
Because those are thin walls, pushing a lot of... Okay, wow. Right, so thank you very much, PCBWay, for sending us this, because this is going to be... I really want to make something nice with these, and I think I'll mark the one that I hammered really hard just in case it fractures. I won't send that to anyone if I give these out or whatever. But now, on to the next project. It might not be sequentially the next video on the YouTube channel, but I want to clean this off because the next project is a laptop that's finally come back to life. Hope you guys enjoyed this video, and thank you very much for watching. See ya.